Good afternoon.
Good afternoon, ma'am.
Great, good afternoon. Chalo. So we'll start with inverse Laplace transforms. Yesterday we have started, but unfortunately we couldn't. So we'll start with the same topic, inverse Laplace transforms. Right? So we have seen the definition, that is, if Laplace of f of t, we call it as f of s, then Laplace inverse is denoted by L inverse of f of s is equal to f of t. This is the definition of Laplace inverse. And what is the main function of Laplace inverse? It transforms which domain?
Yes to T.
S to T, back to domain T. Correct. So yes, we have seen up to this, and after that we have to derive some formula. We will go towards the formula. Yes. So I have given you, I think I have given you one comparison between Laplace transform and inverse Laplace transform. We have started with. So what is the first formula in Laplace transform? We know Laplace transform of 1. What is that?
1 upon
Correct. So in inverse Laplace, the first formula comes to be Laplace inverse of this 1 upon s. It is
1.
1. Laplace inverse on both sides. So here it is Laplace inverse, and Laplace inverse and Laplace get cancelled. So only 1 is there. Okay. Next formula here, it is e raised to at. And that is
1 upon S minus A.
right. So second formula here becomes 1 upon Laplace
Yes,
inverse of 1 upon s minus a. It is
E raised to A.
e raised to at. Correct. Next formula is Laplace of
e raised to minus 80.
E raised to minus
correct,
A.
e raised to minus at. What is that?
1 upon A.
1 upon s plus a. So here it becomes Laplace inverse 1 upon s plus a. It is
e raised to minus 80.
e raised to minus 8. Correct. Next formula, there was, I think, c raised to 80, but we are ignoring it because we never will get like s minus a log c. So if you want to write, you can write, okay? But we are ignoring it here. Next formula we have seen, there was sine 80. What was that sine 80? Laplace?
A upon A square plus A square.
Correct. A upon s square plus a square. So here it is Laplace inverse of a upon, instead that a, I'll just write 1 upon s square plus a square. So what it will be?
1 upon A into sin 80.
Correct. 1 upon, so a is here multiplied, it will go divide there. So it is 1 upon a into sin 80. Remember that. Next formula here was cos, Laplace of cos 80. What is that?
S upon A square plus A square.
On S square
Correct.
plus
Right? S upon s square plus a square. So your formula becomes Laplace inverse. S, we cannot ignore s. Remember, s should be considered. So s upon s ला सोडून नाही करू शकत, जसे इथे a ला सोडून केलं ना. So s is a variable, we cannot leave it. So s upon s square plus a square. What is that?
Cos 80.
cos 80.
Cos 80. Correct. Next formula, Laplace of
Sin
sine
hyperbolic.
hyperbolic 80. What is that?
A upon A square
A
minus A
upon S
square.
square minus A square.
Correct. So here the next formula is Laplace inverse 1 upon s square minus a square. What it will be?
1 upon A sin hyperbolic 80.
Correct. 1 upon a sine hyperbolic 80. Next, Laplace of cos hyperbolic 80.
S upon A square minus A square.
Correct.
Minus A square.
S upon s square minus a square. And here it is Laplace inverse s upon s square minus a square is
Cos hyperbolic.
cos hyperbolic 80. So everything is exactly similar as Laplace. म्हणजे आपल्याला जर Laplace, if we know, we'll easily find the Laplace inverse. Okay, the last formula in Laplace was Laplace of, what was that?
T raised to n.
E raised to n. What is the formula?
n
If we
factorial upon p raised to n plus
right.
s n plus 1.
N factorial upon s raised to n plus 1 if n is
integer,
positive integer, right? And it is gamma n plus 1 upon s raised to n plus 1 in general. Okay, so here I am interested in the formula Laplace inverse 1 upon s raised to n. Okay, so here it is 1 upon s raised to n plus 1, but I want s raised to n here. So what can I consider for n? If I consider n as n minus 1, so minus 1 plus 1 will be cancelled and there will be only s raised to n as required, right? So everywhere I'll consider n as n minus 1. So what is Laplace of t raised to n minus 1? Just
N minus
consider
one
n as n minus 1,
factorial
right? n minus 1 factorial upon s raised to n minus 1 plus 1,
n.
n,
Yeah.
if n is positive integer, and it is n minus 1 plus 1, gamma n, correct? Upon s raised to n
Yes.
in general, right? So from this 2 now I can write the Laplace inverse of 1 upon s raised to n. 1 upon s raised to n, it is here, but this should get divided to this side. So what will be the answer?
1 upon n minus 1 factorial into t raised to n minus
Right.
1.
This should be divided by this. So n minus 1 factorial. But when it is, if
Positive.
n is positive integer, correct? And it is 1 upon s raised to n, Laplace inverse 1 upon s raised to n, that gamma n should be divided here. T raised to n minus 1 upon gamma n if it is in general.
N.
Right, correct. So these are the 8 formulae which we need. Okay, so you have to remember them. And now for you, let me collect them together so that you can remember them. So first formula, and this is Laplace inverse 1 upon s is 1. Can you tell me Laplace inverse 1 upon s square? Okay, wait. Laplace of e raised to at. What is that? Oh, no, we are not at Laplace. Now we are at Laplace inverse. Correct. So Laplace inverse. What is the second formula? 1 upon s minus a. It is. It is. Correct. Correct. Next, Laplace inverse 1 upon
s plus a.
s plus a. It is.
T raised to
Very good. Next, Laplace inverse 1 upon s square plus a square. It is
1 upon a
1 upon a sin
Sin.
at. प्लीज रिमेंबर वरती जर a नसेल तर तो a इकडे आला पाहिजे. इथे a असेल तर दिस इज जस्ट सिम्पली sin at. नेक्स्ट लॅप्लास इनवर्स s upon s square plus a square
cos at.
cos at. Correct. Next, Laplace inverse of 1 upon s square minus a square.
1 upon a sin hyperbolic at.
Correct. Sin hyperbolic, as there is negative sign, but a is not there, so that should be divided on the other hand side. Next, Laplace inverse s upon s square minus a square is
Cos hyperbolic.
very good, cos hyperbolic at. And 8th formula I'll write here. Laplace inverse of 1 upon s raised to n, it is t raised to n minus 1 upon n minus 1 factorial if n is
Positive integer.
right, if n is positive integer, and it is t raised to n minus 1 upon gamma n in general. Right, so these are the 8 formulae we need in inverse Laplace. So can you now tell me Laplace inverse 1 upon s square? Use this. 1 upon s square, n is 2.
t raised to 2 minus 1 upon 2 minus 1 factorial.
right? T raised to 2 minus 1 is
1.
1. T raised to 1 upon 1 factorial is
1.
1. So Laplace inverse 1 upon s square is t. That can also be used as formula. Laplace inverse 1 upon s square is t. Can be the formula or it is covered into this if you don't want the separate formula. So these are 8 formulae important in Laplace inverse. Can I go to questions?
Yes.
Sure. Find first Laplace transform of 1 upon s raised to 5. Which formula?
In
1
general,
upon x
is
1
positive.
upon s raised to n. N is a positive integer, so it is t raised to n minus 1 upon n minus 1 factorial. Is this the formula?
Yes.
Right.
Yes.
So it is t raised to 5 minus 1 upon 5 minus 1 factorial. T raised to 4 upon 4 factorial. So 4 factorial is, I guess, 24.
24.
Yes, that is the answer. What is happening? We are converting s back to the domain t. So answer, whatever we will get, that will totally be in t. Right? Second, next question. Find Laplace O inverse. Now it is inverse. Please pay attention. If it is in S, inverse. If it is in T, Laplace of T, Laplace inverse of S. Okay, the next question. 1 upon S raised to 3 by 2.
t raised to
How?
3 by 2 minus 1 upon gamma 3 by 2.
Correct. That is in general. It is not the integers. It is a general, and formula for the general 1 upon S raised to n is T raised to n minus 1 upon gamma n. So T 3 by 2 minus 1 is
1 by 2.
1 by 2. Upon how we solve gamma, we start with minus 1 to this value. So minus 1 is
1 by 2
1
into
by 2 into
Root
root pi. Very good. So the pi by 2 will go up to the numerator. 2 t raised to half is root t upon root pi. The answer. This 2 goes up. Do you understand that?
Yes.
Right. Sure. Next question. Laplace inverse of 1 upon s raised to half.
t raised to 1 half minus 1 upon gamma 1 half.
T raised to 1 half minus 1 upon gamma half. In general, 1 upon s raised to n formula I have used. That is t raised to
Minus 1 half upon root.
minus 1 half upon root pi. Gamma half is root pi. Very good. So it is t raised to half if it is in denominator, and t raised to half is nothing but root t. So it is 1 upon root t into root pi, or you can write 1 upon root pi into t. Is that correct? Is there any doubt?
No.
No.
Good. Next. 1 upon s raised to 6.
t raised to 6 minus 1 upon 6 minus 1 factorial.
Correct? 6 minus 1 factorial. So it is t raised to 5 upon 5 factorial. So t raised to 5 upon
120.
120. Right. The answer. I hope everyone is understanding.
Yes.
Good. Sure. Next is Laplace inverse 1 upon s square plus 9. You just check in which of the 8 does it go. Like it is 1 upon s
1
square
upon 3 sine 3t.
plus 3 square, right? 9 we can write 3 square. It is 1 upon s square plus a square. You can check the formula. 1 upon s square plus a square Laplace inverse is 1 upon a sine 80. So it is 1 upon.
3 sine 3t.
Very good. Next. Number 6.
6.
Laplace inverse of 1 upon s square plus 25.
1
1
upon
upon
5.
5 sin 5t.
Okay, 1 upon,
5 sin 5t.
correct, correct. It is Laplace inverse of 1 upon s square plus 5 square. A is 5, so 1 upon 5 sin 5t. Next, 7. Laplace inverse 1 upon s square minus 25. If it is s square, na, plus something minus something, we always have a form s square plus a square or s square minus a square. And if it is plus, it is sine. And if it is minus, it is
Hyperbolic.
hyperbolic. So 1 upon 5 into sine hyperbolic 80, a is 5. Correct?
Yes.
Yes.
5. Make the change. Okay, next. Laplace inverse 1 upon s minus 4. What is that?
E raised to
E raised to 4t.
4t.
Very good. 1 upon s minus a. Where it is 1 upon s minus a, it is e raised to at. Negative is the positive, positive is the negative. Yes, it is e raised to 4t. Next, Laplace inverse of 1 upon s plus 5 by 2.
E raised to 5t, 5 by 2t.
Minus 5 by 2t, as it is plus negative. Next, Laplace inverse s upon s square plus 4.
Cos 2t.
Cos
2t.
2t. This is square of something, and that something is your a, right? So it is
Yes.
cos 2t. Very good. Next, Laplace inverse of 1 upon s square minus 1.
1 upon 1 sin hyperbolic t.
Right? 1 upon 1, that is 1. So it is just sine hyperbolic t.
T.
A is 1 here. Okay, the next question then. Number 12. Laplace inverse s upon s square minus 36. S
Cos
upon,
hyperbolic
6.
very
60.
good. As there is negative sign, you should always understand it is hyperbolic, and s above means cos, that is cos hyperbolic 60. Good. Next is 1 s upon s square minus 4.
Cos hyperbolic of 2t.
Very
2t.
good. Cos hyperbolic 2t. And last, Laplace inverse 1 upon s
1.
1. So do you understand now the type? So
Yes.
the thing which we did in Laplace, exactly opposite we have to do it in inverse Laplace. जे formula आहेत as it is आहे, just the way opposite, exactly opposite. Okay, so we go to now methods of finding inverse Laplace transform. Methods to find inverse Laplace transforms. So there are various methods. So out of which we'll go with first method, that is use of standard results. Standard results means formula. The use of standard results. So first question in that comes is find the inverse Laplace transform of 2 by s plus 1 by s cube plus 1 upon s plus 4. So we have to consider Laplace inverse of this, as it is find inverse Laplace. So L inverse of this. So what the property linearity we always used in Laplace also can use in inverse Laplace. Okay, so we have to separate them with the linearity, or here we can always write linearity obeys follows. Okay, so how can we write that?
2 is constant, we can common out that.
2 out, Laplace inverse 1
1
upon s. Very good. Plus
Yes.
Laplace inverse 1 upon
Cube.
s cube.
Yes.
Right. Plus Laplace inverse 1 upon
1 plus 4.
s plus 4. Just separate. Okay, now write the answer. 2 into, what is that?
1. 1.
1. Very good. Plus
E
Laplace
raised to
inverse 1
2 raised
upon
to
s raised to n, t raised to
3 minus 1.
n minus 1 upon
3 minus factorial.
3 minus 1 factorial
E
plus
raised to minus 2t. 4t.
1 upon s plus a, e raised to minus
40.
80. Correct. So it is 2 plus t square upon 2 factorial, that is 2 plus e raised to minus 40, the answer. Next question. Find Laplace inverse of 3s plus 4 upon s square plus 16. Can you tell me what you can do? And always remember, if there is plus here in the denominator in between, you cannot separate like this separate and this separate. So denominator we cannot separate. So this
Can
is
3s upon s square plus 16 plus
correct.
on s square plus 16.
Correct. This is intact, but numerator can separate. Means here it is 3s upon this. So from this 3 is constant will come out s upon s square plus 16 plus 4 upon s square plus 16. This part also. So here 4 is constant will come out Laplace inverse 1 upon s square plus 16. Right, that is
4t.
Laplace, yes, s upon s square plus 4 square. And here Laplace inverse 1 upon s square plus 4 square. Correct. So what is that? S.
Cos 40.
Correct. S असेल, वरती S असेल तर cos असेल. Remember. आणि वरती S नाही आणि खाली हे आहे ऑब्विसली हा s स्क्वेअर प्लस a स्क्वेअर. S असेल तर cos, नाही तर मग sin. पण जर खाली प्लस असेल तर cos's आणि खाली मायनस असेल तर हायपोटेन्यूज. साइन ला पण खाली निगेटिव्ह असेल मध्ये तर साइन हायपोटेन्यूज. Way of remembering. So cos 40 plus 4 into
1 half sin 2t.
1 by
2 sin 2t.
not 2
4.
1 upon a. A is here 4.
Yes. Sorry.
1 by 4, right? Correct. Sin 40. Very good. So 4 get cancelled here. So it is 3 cos 40 plus sin 40. Done.
Yes.
So like linearity, we can just separate and solve it. Oh, any doubt?
No.
Sure. The next question then. Laplace inverse of 3 plus 2s plus s square upon s cube. Can we separate?
Yes.
Yes.
3 upon s cube plus
Right.
2s upon plus
Right.
s square.
Yes. Upon this upon this up. All can get separate. So 3 here will come out. Laplace inverse of 1 upon s cube. From this 2 will come out. Laplace inverse of s upon s cube. And here plus Laplace inverse of s square upon s cube. इथे स्क्वेअर होईल आणि इथे स्क्वेअर जाऊन फक्त s राहील. That is 3, let me write 1 upon s cube plus 2 Laplace inverse 1 upon s square plus Laplace inverse 1 upon s. So what is that?
3 to 3 minus 1 upon 3 minus 1
Correct.
factor.
Laplace inverse 1 upon s raised to n. N is a positive integer, so the formula is t raised to n minus 1 upon n minus 1 factorial plus 2 into Laplace inverse. This is standard also.
T.
T raised to 2 minus 1 upon 2 minus 1 factorial.
Correct. You can write that 2 minus 1 upon 2 minus 1 factorial. A Laplace
Plus
inverse 1 upon s square is t. We know
1.
that. Yes, that is 1. It is 3 into t square upon 2 factorial 2 plus 2 t raised to 1 upon 1 factorial plus 1, and then that is answer. Is there any doubt, anything you want to ask? Please go ahead and ask. So can you solve the next question? Find
Yes.
Laplace inverse of 2s plus 3 upon s square plus 9. Tell me answer. Solve it and tell me answer, please. Done?
Just a minute. Two cos 3t plus 3. Sorry, sin 3t.
3 get cancelled. Only sin 3t. So this is the way we have separated. So 2 into this is cos 3t s upon a square plus a square plus 3 1 upon a sin 3t. 3 cancelled. Yes, the answer. Three s plus 5 upon 9s square minus 25. Sorry. And one more thing. For a standard formula, we need s square. With that s square, there should not be anything extra. So that extra thing you have to take care. It can go into some formula, but it is not initially in the standard one. So what you can do? Standard is like there should be s square only. With that, there should not be anything. So that anything will take out as common. First, from denominator, we take out 9. So numerator as it is upon it is s square minus 9 is common taken out. So it is 25 by 9.
Fine.
Everyone is getting the step?
Yes.
Because we have the formula s square minus a square, but there is something into s square. So that's something you should take out. Now we can separate easily by linearity. 3 here comes out. Laplace inverse s upon s square minus this is the square of 5 by 3. Then plus 5 will come out into Laplace inverse 1 upon s square minus 5 by 3 square. Yes, it is 1 by 9 into 3 into what is that?
Cos hyperbolic 5 by 2t.
Very good. S म्हणजे
Okay.
cos, negative म्हणजे hyperbolic. A is 5 by 3. So cos hyperbolic 5 by 3t plus 5 there.
1 upon 5 by 3. Sin hyperbolic 5 by 3t.
Right. 1 upon A is your 5 by 3. into sine negative असल्यामुळे hyperbolic 5/3 t. 5 will get cancelled and this 3 also will go up upon la upon आहे and 3 will be common, we'll take out. So 3/9 it is. 3/9 into cos hyperbolic 5/3t plus sine hyperbolic 5/3t. There it will be 3, 1/3. You can write if you want. Is the answer. Next, if you are done, solve the next. And those who are solving the last, if you have any problem, please ask. Is it standard?
No.
No. So we have to make it, right? And the standards are like S, there should be S or S square, but that with S there is 4. So what we'll first do? Come on.
1/4 into e raised to minus 5.
Right, you will take out 4 from the denominator. So it is 4 out from both the terms, right? We are taking it common. So दोघातनं काढतोय. So here it is S. आणि इकडे काय होईल मग?
5/4.
5/4. Correct. So yes, it is 1/4 into 1/s plus a.
E raised to minus
E raised to minus 80. Done. इथे जर निगेटिव्ह असता तर इकडे प्लस झाला असता. That only is the change. चल next. Laplace inverse of 4s plus 15 upon 16s square minus 25. Do this. What is the first step we will do?
1/16 will
16.
16. Correct. 16 you will take out first. So it is Laplace inverse of 4s plus 15 upon s square minus, what is the term here?
25/16.
25/16. Very good. Right. So now we can separate that 1/16 is for both if we'll separate. So from this 4 will come out. So 4/16 into Laplace inverse s upon s square minus 5/4 square. 25/16 म्हणजे 5/4 square. Plus 1/16 is already there. 15 also comes out. 15/16 into Laplace inverse 1 upon s square minus 5/4 square. Okay, if you have any problem in this, please ask. So it is 1/4. S means cos and negative means hyperbolic. Right. Cos hyperbolic, very good. 5/40 plus 15/16 into
5/4 sine hyperbolic 5/40.
4/5.
1 upon a.
1 upon
So
5/4.
1 upon 5/4 into sine hyperbolic 5/4 t. 1 upon a sine hyperbolic 8. So here it is 4 and here it is 3. That is 1/4 cos hyperbolic 5/4 t plus 3/4 sine hyperbolic 5/4 t as your answer. I hope you're understanding now.
Yes.
And every time you will check that your answer is coming into t. So we are yes converting back to t. Whatever we have converted into s by using Laplace, by using inverse, again to t, back to t. Next question. Laplace inverse of s square minus 1 square upon s raised to 5. What you will do first?
We can separate numerator.
We can expand.
But if you separate the numerator, there is square. You should first take the
Separate
square.
expansion.
First take the square. What is that square? A minus b square. A square
Minus 2ab.
minus 2ab plus b square plus 1 upon s raised to 5. Now you can do this. S raised to 4 upon s raised to 5. 1 upon s. Minus 2 Laplace inverse s square s 5 s cube plus Laplace inverse 1 upon s raised to 5. What is this? 1
1
minus 2
t raised to 3 minus 1
minus
upon 3
1,
minus 1
2
factor.
factorial.
correct, plus,
T raised to 5 minus 1 upon 5 minus 1 factor.
very good. So it is 1 minus 2 t square by 2, 2 cancel, plus t raised to 4 by 4 factorial. Is your answer. Chala, we'll take one question. You will solve this. Find Laplace inverse of s plus 3 upon s square plus 4. Tell me answer by solving. What is the answer?
Cos 2t plus 3 cos 2t.
Cos 2t plus, now 3 cos,
2t.
no, Laplace inverse s upon s square plus 2 square plus 3 into Laplace inverse 1 upon s square plus 2 square. That is cos 2t plus 3 into 1 by a
1
1
by
by 2 sine 2t.
sin 2t.
Yes.
Answer. S is not there. This is 3.
1 upon s.
Right?
Yes.
So this is all about like using the standard formula. You can convert by linearity into the standard formula and solve. So next method, method number 2. Second method, method 2 we can write, is by using first shift property. First shift property. So in Laplace, we'll write the statement in Laplace. If Laplace of f of t is f of s, what was the first shift? Then Laplace of,
to 80 into f of t is
right,
equal to f of s minus 1 a.
f of s minus a, and Laplace of e raised to minus at f of t
F of
is
s plus a.
f of s plus a. Now, I have to define this exactly opposite. If Laplace inverse of f of s is what? F of t. Exactly opposite. दोन्ही बाजूला Laplace inverse apply करत चला. Laplace inverse of this is f of t. Then Laplace inverse of f of s minus a will be what?
E raised to 80
E
into
raised to 80 into f of t. पण f of t म्हणजेच काय? Laplace inverse f of s. सो एस मायनस ए जिथे जिथे एस आहेत तिथे सगळीकडे जर एस मायनस ए दिसत असतील तर ते जो ए आहे यू कॅन टेक इट आउट एज e raised to at and there will be only Laplace inverse of f of s, and which we know the answer. We can directly multiply and solve. And Laplace inverse of f of s plus a will be what?
E raised to minus 80.
E raised
E
to
raised to minus 80 into f of t, but f of t is Laplace inverse of f of s. Okay, so please understand this. Let me take, this is the statement in inverse, exactly the opposite statement. Please write it properly. Can I go to question now?
Yes.
Okay, like if the question is find Laplace inverse of 1 upon s minus 2 bracket square. Now you will see wherever is s, wherever is s, is it s plus something or s minus something? If it is, it goes in first shift, right? In this, there is s, and wherever means there is only one s, and s is with s minus something, so it goes in first shift. आणि कसा जाईल फर्स्ट शिफ्ट मध्ये एस जिथे आहे तिथे सगळीकडे जर एस मायनस ए असेल तर तो जो काही ए आहे तो ई रेस टू एटी बनून बाहेर येईल. सो इथे काय होईल ई रेस टू दिस
Two.
नंबर. वेट याला 3 करा, सगळं 2 नको परत कन्फ्युजन. कुठला 2 3 करा. हा आता एस मायनस 3 झाला, काय बाहेर येईल ई रेस टू
3t.
3t बाहेर येईल आणि त्या 3 चं काम इथे संपेल, ह्या ए चं काम इथे संपेल आणि राहील फक्त लॅपलास इन्व्हर्स ऑफ एफ ऑफ एस. ए लिहिणार नाही होत आपण कारण ए इथे आला बाहेर ई मध्ये. सो इट इज देन इनटू लॅपलास इन्व्हर्स 3 लिहायचं नाही, बाकी सगळं ऍज इट इज 1 अपॉन एस त्याचा स्क्वेअर ऍज इट इज. गॉट दिस स्टेप?
Yes.
Everyone is getting?
Yes, ma'am.
Wherever, just remember my word, wherever, not only at one place, wherever is s, there should be s minus 3. Then you can take it out, e raised to 3t, and once it is out, it roll will get over. You will cut it and there will be only s square. Right, so now we know this. We'll write it e raised to 3t into
T.
t. Very good, done. This is your answer. Is there now any doubt you can ask? Next question, if you don't have any problem. Laplace inverse of s plus 1 upon s plus 1 square plus 3 square. So wherever is s na, that is not standard. Standard is s square plus 3 square. It is standard, but s is with s plus 1. And wherever is s, is it s plus 1 there?
Yes.
Right. So it goes in first shift. So what will come out?
E raised to minus 1.
Very good. If it is s plus a, e raised to minus 80 comes out. मायनस असेल तर तो प्लस होतो ई रेस टू प्लस, आणि प्लस असेल तर ई रेस टू मायनस होतो. ए आहे तुमचा 1, सो ई रेस टू मायनस 1 टी, आणि ह्या 1चं आणि ह्या 1चं काम संपलेलं आहे. सो व्हॉट रिमेंड इज एस अपॉन
A square.
एस स्क्वेअर प्लस 3 स्क्वेअर. बाकी सगळं ऍज इट इज. फक्त एस प्लस 1 आहे ना, तो त्याचं काम झालंय प्लस 1चं, बाकी सगळं काही चेंज करू नका. सो इट इज ई रेस टू मायनस टी इनटू व्हॉट?
Cos 3t.
Cos 3t. Done by using first shift. Everyone is clear?
Yes.
Chalo, so can we go to the next question? Find the inverse Laplace transforms of the first question is, find this Laplace inverse s plus 2 upon s square minus 4s plus 13. Before that, थोडंसं easy घेऊया. हे राहू द्या. हे आहेच आहे पुढं. थोडा easy घ्या. For you, 1 upon s minus 2 raised to 3 by 2. काय होईल बोला? e raised to
2t.
व्हेरी गुड. जिथे s आहे तिथे s minus 2 आहे, सो 2 बाहेर येईल यात e raised to 2t आणि काय राहील तिकडे?
Yes.
3 by 2.
Very
by
good. 3 by 2. So it is e raised to 2t into, what is that?
T raised to 3 minus 2 upon gamma 3 by 2.
Correct. Gamma of 3 by 2. So you will solve this half, I guess, upon, you start with minus 1, so half into
By
root
2
5. Very good. So here 2 goes up, 2 e raised to 2t into root t, this is upon root 5. T raised to half म्हणजे root t. Done. Next question. Laplace inverse of 1 upon s minus 2 square plus 2 square.
E raised to 2t
Very good.
into Laplace of s plus 2 square.
S square plus 2 square.
Right, that is what? 1 upon
Into sine
sine
2t.
Done. Next. Laplace inverse s upon s minus 4 square plus 5 square. Wherever is s, is it s minus 4?
No.
E raised to
No.
4t.
No. First thing is no. Your answer should be no. It is not. So we have to, can we obtain it? Wherever is s, can we obtain s minus 4? Because it is here. So is it possible to obtain it everywhere wherever is s? Yes, it is
Yes.
possible. How?
Add
S minus 4 plus 4. Add and subtract. So yes, s minus 4 comes. S minus 4 square plus 5 square. So now wherever is s, I can see s minus 4. Correct?
Yes.
Yes.
Now, what is it? E raised to
4t.
40. Very
40.
good. Minus असेल तर plus into Laplace inverse. याचा आणि याचं काम झालंय. Right. S plus 4 upon
S
s square plus 5 square. It is e raised to 40. If we separate s upon s square plus 5 square, that is what?
Cos
Cos
5t.
Cos 5t plus 4 upon 4 will come out.
4.
1 upon 5.
Square plus 5 square.
1 upon 5.
Upon 2 sin 2t.
1 upon 5 sine 5.
Sine 5.
Equal.
Correct? Eh?
Yes.
This is how first shift works. जिथे जिथे यस आहे तिथे तिथे सगळीकडे आयदर एस प्लस एस मायनस ए आहे का बघा. असेल तर तो ई च्या पॉवर मध्ये बाहेर काढा. यू नो हाऊ. नसेल तर तो तिथे ट्राय करा लिहिता येईल का. अँड जर हे झालं then only you can apply first shift. We'll solve one more. Okay, now we'll take that question. Laplace inverse of s plus 2 upon s square minus 4s plus 13. The most of the things in Laplace inverse comes from the denominator. If a denominator is in the standard 1 formula, we can easily solve. आता हा आहे का standard denominator?
No.
एस स्क्वेअर प्लस ए स्क्वेअर पाहिजे, पण तिथे एक एक्स्ट्राच काहीतरी 4s दिसतंय. ठीक आहे, मग ह्या एसचा आपण काही करू शकणार नाही, काढू नाही शकणार. एस कॉन्स्टंट असेल तर काहीतरी करू, व्हेरिएबलला काही नाही करायचं. मग काय करू शकतो विचार करा आणि सांगा. आपल्याला माहिती एस प्लस समथिंग झाला किंवा एस मायनस समथिंग झाला तर तो फर्स्ट शिफ्ट म्हणून बाहेर येईल च्या पॉवर मध्ये, आणि मग फक्त एस स्क्वेअर राहील आणि सॉल्व्ह होईल. मग त्याच्यासाठी तुम्ही ह्या पहिल्या दोन टर्म बघा, हा कशाचा तरी स्क्वेअर मधल्या टर्म्स दिसत आहेत का?
Yes.
कुठला
Two.
स्क्वेअर? हा, याचे हाफ करून बघा. नंबरच्या 4च्या हाफ काय?
2 root
Two.
s.
हाफ चेक करून बघा बरं. स्क्वेअर मध्ये निगेटिव्ह आहे म्हणून निगेटिव्ह ठेवा. दिस इज एस and half of this 4, that is 2. So try this, is s square minus 4s plus 4, right? So there are these two terms, s square minus 4s. पहिले डिनॉमिनेटरचा विचार करूयात, न्यूमरेटर राहू द्या तसाच. सो इट इज s square minus 4s, आणि मला 4 हवाय फॉर दिस स्टँडर्ड स्क्वेअर, सो आय राईट प्लस 4, आणि
Minus
because I
4.
have added, so I should subtract minus 4, and they're 13 as it is. Are you getting the steps now?
Yes.
You are
Yes.
trying to make it a perfect square. And from this number, I have identified this is the square of this, right? For this square, we'll need 4, so I have added, subtracted, baki sab as it is. So it is Laplace inverse of s plus 2 upon, from this, it is nothing but s minus 2 bracket square. First three terms are. And now this is 13 minus 4. 30 minus 4? 9 plus 9. Is it plus 9?
Yes.
Right. But now it is s plus 2 and it is s minus 2. काय चेंज केलेलं परवडेल आपल्याला? हे तर आपण चेंज नाही करू शकणार ना, कारण हे आपण एवढी मेहनत करून हे s minus 2च राहणार, कारण इथे निगेटिव्ह साइन आहे. म्हणजे याचा आपण प्लस 2 नाही करू शकत, मग याचा मायनस 2 करू शकतो का?
Yes.
राईट.
Yes.
सो हाऊ इज इट? जे आपल्याला हवंय ना ते आपण लिहून टाकायचं बिंदास. आपल्याला हवाय एस मायनस 2, ठीक आहे. मायनस 2 हवाय, प्लस 2 करा, मायनस 2 ऍड केला, प्लस 2 केला, आणि आहे तो ऍज इट इज प्लस 2, कारण मला एस मायनस 2 पाहिजे म्हणून. अपॉन एस मायनस 2 स्क्वेअर प्लस 9. इथपर्यंत काही प्रॉब्लेम?
No.
No.
कारण इथे एस मायनस 2 आलाय आणि जिथे जिथे एस असेल तिथे मला सगळीकडे एस मायनस. हॅलो, एम ऑडिबल?
Yes.
Yes.
सो जिथे
Yes,
जिथे,
ma'am.
हा, जिथे जिथे एस आहे एस मायनस 2 हवाय. ओके, सो एस मायनस 2 मी इथे आणलाय, मायनस 2 आणल्यामुळे प्लस 2 केला, आणि पहिला ओरिजिनली 2 आहे तो तसाच लिहिलाय. ठीक आहे. आता हे झालं तुमचं लॅपलास इन्व्हर्स. व्यवस्थित लिहिते, एस मायनस 2 प्लस 4 अपॉन एस मायनस 2 square plus 9. Now wherever is s, is the s minus 2?
Yes.
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 So it becomes e raised to
2t.
2t. Very good. So it is e raised to 2t into Laplace inverse s. हा 2 गेला बाहेर, हा पण 2 गेला बाहेर, इथे राहिला s plus 4,
4.
आणि डिनॉमिनेटर मध्ये
S square plus 9.
good. So it is s plus 4 upon s square plus 9. Now we can separate, e raised to 2t is there, then into Laplace inverse of s upon s square plus 3 square plus 4 out, Laplace inverse 1 upon s square plus 3 square. Okay, so it is e raised to 2t. And what is this?
Cos 3t.
Cos 3.
Very
Cos
good. Cos 3t. Plus 4 is there. 1 upon is what?
1 upon 3
1
into
upon 3
sin
sin
3t.
3t.
Very good. 1 upon 3 into sine 3t. Nice. The answer, e raised to 2t cos 3t plus 4 by 3 sine 3t, and done. This is your Laplace inverse of s plus 2 upon s square minus 4s plus 13. So do you understand now?
Yes.
Yes.
Try to write it as s minus or s plus in first shift. And if it comes in first shift, you can easily solve. Please wait, let me take attendance. Do not leave. If you have any doubt in between, you can ask me. No one will leave, please wait. Chalo, done. Please stop. Thank you.